In this video, I'm going to talk about Cartesian products. Cartesian product is something you have already seen in calculus. Cartesian product of sets is generalization of that concept from calculus. We know that we denote R as the real numbers and think of R as the line. And then we have R2 as the plane, and elements of R2 are pairs of elements x and y, such that x is a real number and y is a real number. Turns out this is a special case of a Cartesian product. So a Cartesian product of two sets denoted S cross T is just the set of elements x and y, is a set of pairs x and y, such that x is in S and y is in T. That's it. Is take an element of x, take an element of t, and put them together, and take all possible x's and y's, such like this, and that creates for you the Cartesian product. It's important that you take all the possible x and y's. So example, let's say S is, I'll use colors, 1, 2. And let's say T is 2, 3, then S cross T is I have to take every possible value of S and pair it with every possible value of Y. So I can take 1 and pair it with the 2, or I can take 1 and pair it with the 3, or I can take 2 and pair it with the 2, and I can take 2 and pair it with the 3. Now let me put all the commas. So that is my S cross T. It contains 4 elements. Similarly, I can do S cross S. If I were to do S cross X, so I'll get 1, 1, 1, 2, 2, 1, 2, 2. Note that here the first elements are coming from this S, and the second elements are coming from the second S. That's why 1, 2, and 2, 1, these pairs are different pairs. They're pairs, they're not sets. So very important remark. A pair is not a set, so the pair 1, 2 is not the same as the pair 2, 1. So that's how you form Cartesian products. And we saw the example above, R2 is nothing but R cross R. And so it's x and y, such that x is a real number and y is a real number. More generally, if I take set S and I multiply it with itself n times, then this is denoted Sn. And so this is the generalization of R2. I can make R3, which will be R cross R cross R, which will be X, Y, Z, such that X and Y and Z are all real numbers. And final example that is relevant in computer science is I can take S to be the set 0, 1, and I can form Sn, which is 0, 1 cross 0, 1. The elements of Sn are called binary strings. Now, one last thing I want to say about Cartesian product is, I want to call it a fact. Again, we will do this more properly when we do combinatorics, but it is something that you should know right now, and that is that the size of the Cartesian product is the product of the sizes. And we saw in the example above, when S was, let me do another example. Let's take S to be 1 and let's take T to be AB, then S cross T will be 1A, 1B, and that's it. And so I get size of S cross T is 2, and size of S cross size of T is 1 times 2, which is also 2. Here's something slightly confusing about Cartesian products. We can take Cartesian product of any two sets. They can even be sets of sets. So in principle, you can take Cartesian product of power sets and so on. We won't go into that, but this is something you should know. You might encounter this randomly. You can take Cartesian product of the empty set with anything. And this will be, if you think about what this is X and Y, such that X is in the empty set and Y is in T. But the empty set contains nothing. So there cannot be an X that is chosen from the empty set. So what you will get is that phi times T is just phi. So the product of an empty set with anything is just the empty set. And this also checks out with fact above. The size of empty set cross T should be the size of empty set cross the size of T, and an empty set size is 0. I should add here when this only makes sense when they are finite. And that is the same as the size of the empty set. Okay, so you can take Cartesian product even of the empty set and you will get the empty set back. So in a way, the empty set is like the 0 number. You multiply anything with 0, you get 0. You multiply anything with the empty set and you get the empty set back.